Welcome. Today, we are going to explore a field that is fundamental to modern life, yet often misunderstood. We are asking the question, what exactly is chemical engineering? There is a common misconception that we need to address right away. Many people assume that chemical engineering is simply big chemistry. They imagine it is just what chemists do, but in larger beakers. However, that is not accurate. It is, in fact, a unique and broad branch of engineering that stands entirely on its own. To understand the difference, we have to look at the scale of operation. Consider a traditional chemist. A chemist might discover a new, groundbreaking reaction inside a small lab vial. This is discovery. But the chemical engineer has a different task. They must figure out how to make that same reaction happen on a massive, industrial scale. This transition from a test tube to a plant is not simple. To do this, the field combines chemistry with several other disciplines, specifically physics, math, and economics. Engineers use these subjects to design, build, and operate industrial processes. It is a complex balancing act. The engineer's responsibility is to ensure the process is not only scientifically possible but must also meet two critical real-world criteria: it must be safe, and it must be profitable. To understand how engineers achieve this balance of safety and profit, we must look at the core principles, the main pillars of the field. The first pillar involves separation processes. When we look at nature, materials are rarely found in a pure state. We often find them mixed together with other elements. However, industry requires purity. Therefore, engineers use specific methods to separate these mixtures into pure, usable components. You may be familiar with techniques such as distillation or filtration. These are the primary tools engineers use to achieve that necessary purity. The second pillar is reaction engineering. This principle moves beyond just the chemistry of the reaction and focuses on the equipment. It involves designing reactors. The engineer must meticulously calculate the correct size and shape of the vessel. This is crucial because they must ensure the chemicals interact correctly inside that vessel to create the desired product effectively. The third pillar is process control. Once a plant is built, it must remain stable. This field focuses entirely on making sure the plant runs safely and efficiently over time. It is not enough to just build the plant, one must maintain it. Engineers use automated systems to monitor critical variables, specifically temperature, pressure, and flow rates, to prevent accidents and ensure consistency. The fourth and final pillar is transport phenomena. This represents the physics of the process. It is the study of movement. Specifically, it studies how heat, mass, and momentum move through the system. For example, an engineer needs to understand exactly how fluids flow through pipes or how heat transfers to cool down a reactor to keep it from overheating. Now that we understand the theory, what is the practical output? You might not realize it, but chemical engineers are involved in making almost everything around you. Let's look at the energy and materials sector. Engineers turn crude oil into fuels like gasoline. But beyond fuel, they also create the plastics we use every day, from containers to packaging. In the healthcare sector, they are vital. They work in the life sciences to manufacture medicines and pharmaceuticals. Their work ensures that pills and vaccines are available for everyone who needs them, producing them at a scale that can reach a global population. They're even essential in the technology sector. Chemical engineers help manufacture the silicon wafers used for computer chips, also known as semiconductors, which power our digital lives. They also play a major role in what we eat. They design processes for food and beverages. The goal here is to keep food fresh and safe for consumption, managing preservation and packaging processes. Furthermore, they are key to the future of energy and health. They help create powerful batteries for modern electronics and design systems that provide clean water to cities. Finally, we must ask, why does this field matter? Chemical engineering is not just about making products. It connects to big-picture issues that affect our future. It is the driving force behind sustainable energy solutions as we look for new ways to power our world. It also plays a critical role in environmental protection. Engineers are constantly finding ways to reduce waste and pollution, ensuring that industrial progress does not come at the cost of the planet. Additionally, the field focuses heavily on workplace safety. By designing safer processes and equipment, chemical engineers protect workers from hazards and accidents, ensuring that the people running the plants are safe. Ultimately, it is a field that uses science and math to make the world safer, cleaner, and more efficient.